Inverse functions. Objectives. Theorems on composite functions, inverse functions. If f maps from A to B, G maps from B to C, H maps from C to D are functions, then H circle of G circle F equals to H circle G circle F. If f maps from A to B, IA and IB are identity functions on A and B respectively, then F circle IA equals to F equals to IB circle F. Inverse function. Let f be the function that converts temperature in degrees Celsius to a temperature in degree Fahrenheit. F equals to f of C equals to 9 by 5 multiplied by C plus 32. Then, its inverse function converts degrees Fahrenheit to degrees Celsius. C equals to f inverse of f equals to 5 by 9 multiplied by f minus 32. Inverse function is finding a rule which takes the output and gives input. If f maps from A to B be 1, 1 onto bijection function, then the mapping f inverse maps from B to A, which associates each element B belongs to B with element A belongs to A such that f of A equals to B, is called the inverse function of the function f maps from A to B. F inverse maps from B to A, f inverse of B equals to A, implies f of A equals to B. In terms of ordered pairs, the inverse function is defined as f inverse equals to order pair B, A if A, B belongs to F. For the existence of inverse function, it should be 1, 1 and onto. Properties of inverse function. Inverse of a bijection is also a bijection function. Inverse of a bijection is unique. If f and g are two bijections such that g circle f exists, then g circle f whole inverse equals to f inverse circle g inverse. If f maps from A to B is a bijection, then f inverse maps from B to A is an inverse function of f. F inverse circle f equals to IA and f circle f inverse equals to IB. Here, IA is an identity function on set A and IB is an identity function on set B. If f maps from A to B be a bijection function, then f is a bijection if and only if there exists a function g maps from B to A such that f circle g equals to IB and g circle f equals to IA, and in this case g equals to f inverse. Illustration 1. The inverse of the bijection function f maps from r minus 5 to r minus 2 defined by f of x equals to 2x minus 1 upon x plus 5. We have f circle f inverse of x equals to x, implies 2f inverse of x minus 1 upon f inverse of x plus 5 equals to x. Implies f inverse of x multiplied by 2 minus x equals to 5x plus 1. Therefore, f inverse of x equals to 5x plus 1 upon 2 minus x.